Hi there, welcome to this short video where we'll quickly go over some of the intuitions of why taking the rotational element around the y-axis is actually able to be done by taking the inverse function and simply doing a rotational element around the x-axis from f of b to f of a. We will do the example with our function 4 minus x squared, but also show that this holds true for any function. Let's first observe our function here. We see that for any given interval here, we have two shaded areas. We have a red area, which represents the area we would rotate around the x-axis, and a blue area, which represents the area we would rotate around the y-axis. The red area is bound by the interval a and b, while the blue area is bound by the interval f of b and f of a. Now, we can also look at our inverse function here, where we again have a red area and a blue area. The blue area again being bounded by f of b and f of a, and the red area by a and b. Now, if we show both at the same time, we can actually see that the area of the red areas are the same, and the area of the blue areas are also the same. This is important because the blue area on f of x represents the rotation around the y-axis, while the blue area on the inverse function represents the rotational element around the x-axis. We can move around our intervals a little bit, see that this holds true for any interval on our function. We can also start a fancy little animation we have here. If we're not completely convinced, and it will cycle through a bunch of different combinations of intervals. Lastly, I quickly want to show that this does not only hold true for our 4 minus x squared. So I've introduced a little control here where we can change the constant in front of our x squared. So before it was minus 1. Now we can set it to, let's say, minus a half. And we have the constant control that we're adding. So the 4 we can set to a higher value, such as 4.7, or we can set it to a lower value. And if we now observe some random intervals on these new functions, we see that the red areas are proportionally the same, and the same with the blue, they always remain the same. So that means that these two equations on our right does not only hold true for our given f of x, 4 minus x squared. I should perhaps mention that one requirement for all of this is, of course, that the inverse function needs to exist over the interval we want to rotate around, which in this case holds true, but not all functions have an inverse function.